Have you ever wondered how the energy of flowing water can be converted into mechanical work? This application can be demonstrated using a water wheel by applying a thermodynamic concept into our daily life situation. That's why our team consists of me, Yasmin Zahira, Nick Yozarin, Ruhaya, Amir Azfar, Khadija Aisha, and Gabriel study and analyze the thermodynamic concept behind a water wheel system we've seen in our daily life.
Water mills may look simple, but they actually represent one of the earliest forms of renewable energy. The key principle is that it uses continuous flowing water to produce mechanical power without fuel. In the past, water mills were used to saw timber, grind minerals, and operate textile machinery. In some rural areas, smaller water mills were used to power workshops and support local industries long before electricity was existed. Today, the same principle is still used in modern systems. For example, a hydropower plant, which uses the flowing water to turn its turbines, which is essentially another form of a water mill. Through this, we're able to see how our prototype connects to the real world, using natural flowing water to produce useful forms of energy in a sustainable and low-impact way.
For our project, we will be demonstrating how the first law and second law of thermodynamics works in an open system using a simple 3-bottle water wheel model. The first law of thermodynamics is the law of conservation of energy. It tells us that energy cannot be created or destroyed. In the context of a water wheel, the energy going into the system must equal the energy coming out. The water brings in potential and kinetic energy, and that total energy simply gets converted into other forms, mainly mechanical energy, which turns the wheel, plus other forms of energy that leaves with the water. So the first law is about energy balance. The second law of thermodynamics focuses on entropy and efficiency. It tells us that every real process has unavoidable losses. For a water wheel, this means that some of the useful energy always becomes wasted energy, like friction, turbulence, and heat, increasing the entropy of the surroundings. Because of this, the water wheel can never be perfectly efficient, no matter how well it is designed. The second law reminds us that although energy is conserved, not all of it can be turned into useful work.
So moving on, we will go to the assembly part. So these are the materials that we need. We need 3 bottles, 10 plastic straws, 1 wooden stick, and some scissors or cutters, and also glue or maybe hot glue to seal the holes. So right here, you can see there are 2 holes that we have cut at the bottom bottle, and at the side bottle we have also 2 holes, one on the side and also one at the top. And for the top bottle, we will need to cut 2 holes, one at the bottom here to link with the side bottle, and another one in the front to link with the bottom bottle. And we will also need to cut a big hole on top to fit the input and also the wheel. So after cutting the holes, we will now insert the straws. So we will have 1 straw connecting the top bottle and the bottom bottle, as you can see right here, and also another straw to connect the bottom bottle and the side bottle. So this is where the water will flow into the second bottle, and we will have a last straw connecting from the side bottle to the top, back to the top bottle, and feeding the water through the wheel. So after we insert the straws, it's time for the wheel. So as you can see here, for the wheel, we will cut the plastic straw into small short pieces. So after cutting into short pieces, we will cut diagonally here. As you can see, there's an angle diagonal here, so that when the water flows, this wheel here will turn more easily. And after that, we will glue it together, and we will penetrate a wooden stick through the wheel so that it can turn.
Today I will explain the working mechanism of our water wheel prototype. The system uses 3 plastic bottles and straw to create continuous water circulation flow?
First, the water stored in the upper bottle possesses gravitational potential energy. As it flows downward through the straw, the potential energy is converted into kinetic energy of the moving water.
When air is compressed in the bottom bottle, the pressure pushes water up into the top bottle. From there, the water flows down due to gravity and hit the wheel.
When the water jet strikes the turbine blade, it transfers part of kinetic energy through a momentum exchange, producing a tangential force on the blade. This force creates torque, causing the turbine wheel to rotate.
The process demonstrates the real thermodynamic concept, which is potential energy convert to the kinetic energy and kinetic energy convert to the mechanical work. Some energy is lost due to friction, turbulence and splashing, but overall design clearly show how flowing water can power a rotating turbine using simple recycled material.